Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. Today our topic is measurement of inflation. Means that how we can measure increase over time in the overall price level. How we can calculate, how we can estimate inflation rate over time. Over time means between the two time periods. So the government use different tools to measure inflation rate over time. One is GDP deflator and other is consumer price index. Difference between the two tools is this: the GDP deflator is used to measure increase in the overall price level over time between the two time periods, and consumer price index is used to measure increase in the prices of the goods and services for which the consumer pay. So we are discussing GDP deflator, as this is an instrument tool that government used to measure overall inflation rate over time, or you can say between the two time periods. The formulation is the ratio of nominal GDP to the real GDP multiplied by 100. This formula we can use to measure inflation, overall inflation rate. GDP deflator for the base year is always 100%. What is base year? The year from which we consider that prices will remain fixed. That year is called base year, as we define real GDP. So we discuss over there base year prices, constant set of prices. Here we are again calculating real GDP, and we will take some constant set of prices for computing real GDP, and that year from which the prices does not change, that is called base year. So one thing should be clear to you students, that GDP deflator value inflation rate for the base year will always be 100%, because for the base year nominal GDP and real GDP will be same, and when we put in the formula, so it will give us the 100% result. So for the base year GDP deflator inflation rate always will be 100%. I am putting one example to show this thing with example. Suppose this is the price of 2019 10, this is the price of marker, and in 2019 Q quantity, that is quantity of the marker in 19. Price of the same marker in 2020, that is 20, and price of the same quantity of the same marker in 2020, that is 200. These are the information. Price of 1910, quantity of 2019 100, and the same commodity marker price in 2020, that is 20, and quantity in 2020, that is 200. Now we find GDP deflator for 2020. So GDP deflator for 2020 formula is again the ratio of nominal GDP to the real GDP multiplied by 100. Nominal GDP divided by real GDP multiplied by 100. Now I am going to compute nominal GDP, then real GDP, and then we will substitute the values in this formula and we will compute the ratio. So we will find out inflation rate between the 2 years 19 to 20. Nominal GDP for the 2020, price of 2020 multiplied by quantity of 2020. Nominal GDP for the year 2020 is equal to price of the 2020 is 20 and quantity of the 2020 is 200. So the nominal GDP for the current year 2020, that is 4,000. Now we are going to compute real GDP, because in the formulation we have nominal GDP and real GDP, and the year is 2020. So nominal GDP we compute 4,000, and now we are going to calculate real GDP for the 2020. So in the real GDP we are using some base year prices, yani price remain constant. So we will use in this formula the price of 2019. It means price does not change between the year. From 19 to 20 price remain same, and we will use the quantity of current year 2020. So price of 19 is 10 and quantity of 20 is 200. When we multiply, we find out the real GDP in the 2020, that is $2,000 billion. It's mean that price between the 2 years, yani from 19 to 20, does not change and quantity double. That is why GDP double, and this is the real actual growth of the economy. Now we put the GDP deflator, nominal GDP divided by real GDP multiplied by 100. We put the values and we calculate GDP deflator 200%. So 200% is the inflation rate in 2020. Now to calculate the inflation rate between the 2 years over time, yani from 19 to 20. So we will subtract the 100% inflation rate in 19 from the 200% inflation rate in 2020. So we will find out the inflation rate in the economy between the 2 years 19 and 20. Inflation rate between 2019 and 2020 is equal to GDP deflator for 2020 minus GDP deflator of the base year. So as I told you in the very beginning in the note that for the base year GDP deflator is always 100%, and for the current year 2020 we calculate that is 200%. We feed in this formula 200% minus 100%, and we calculate inflation rate between 2019 and 20, that is 100%. Interpretation is this, that in the year from 19 to 20 the inflation rate 100% increase, the price is doubled, and this is also very clear that price in 19 was 10 and in 2020 now this is double 20. So this is increase in the prices. This is increase in the overall price. I'm again repeating this GDP deflator. GDP deflator is an instrument which measure increase in prices over time. And it's mean this is a tool that the government use to measure overall inflation rate, to measure increase in the general price level over time between the time periods. The formula that we are using, GDP deflator is equal to nominal GDP divided by real GDP multiplied by 100. So its mean GDP deflator is the ratio of nominal GDP to the real GDP. One thing I'm writing as a note, that GDP deflator for the base year is 100%. Why? Because in the base year nominal GDP and real GDP is the same, and when we calculate, when we put in this formula, so automatically it will give us the 100% result. So in the base year inflation rate always will be 100%. Now I'm going to clarify this with one example. Suppose this is the price of marker in 2019, that is 10. The quantity of the same marker in 2019, that is 100. The price of the marker 1 year later in 2020, that is 20, and double. And quantity in 2020 is 200, again doubled. Now the question is this, compute GDP deflator for 2020. So we know that this is a tool to measure inflation rate over time, to measure increase in prices over time, and the formula we have. GDP deflator for the year 2020 we are going to compute, and this is the ratio of nominal GDP for the year 2020 divided by real GDP for the year 2020 multiplied by 100. So we need these two things, nominal GDP and real GDP, and we studied this in the previous lessons also, that how to compute nominal GDP. Nominal GDP for the current year 2020 is equal to price of current price multiplied by current quantity. So price of 2020 multiplied by quantity of 2020, the values you have, the price of 2020 of marker is 20, the quantity is 200. I'm putting in here price of 2020, quantity of 20, 200, and the result is 4,000. So its mean nominal GDP is 4,000, which double. Why? Because quantity also double and price is also double. Now we are computing real GDP, and again we study in the previous lesson, real GDP is the GDP that we compute at some constant set of prices. We are assuming that price does not change over time. We will use the price of base year. In here we have base year 19. So real GDP is the base year price 2019 because 19 is base year, and the quantity we will use current 2020. So the price of marker in 19 were 10 and the quantity of marker current in 2020, that is 200. When we multiply, we find out the $2,000 billion GDP. This is the real GDP. Because the prices remain same. We keep prices constant. Price does not change in this 1 year because we are using the prices of 1910 and we are using again the same price of 1910 in 2020. So price remain fixed. This is base year price, and base year price mean prices does not change. Now we put nominal GDP and real GDP in this formula. GDP deflator is equal to nominal GDP as we compute $4,000 and real GDP as we compute $2,000. We put in this formula nominal GDP divided by real GDP multiplied by 100, $4,000 billion divided by $2,000 billion multiplied by 100, and when we calculate, we find out GDP deflator for the year 2020, that is 200%. So we compute 200% inflation in the year 2020. Now how we can find out increase in the overall price level between 19 and 20, inflation rate between the 2019 and 2020, we can compute by subtracting the value of GDP deflator of base year from the value of GDP deflator of current year. So GDP deflator of current year 2020 minus GDP deflator of base year, that is 2019. So the GDP deflator that you calculate, that is 200% in 2020, we feed here, and the GDP deflator for the base year, as I told, I write there in the note, that is 100%. So 200% minus 100%, we find out the 100% inflation rate in this 1 year. It's mean between 2019 and 2020, the overall price level increase 100%. 100% mean prices are double. Interpretation is this: price is double, 100% increase over time. Now we are proceeding toward another chapter, determination of equilibrium output level. In this section, we will learn about the simple closed economy, two sectors economy, the economy in which we have only two sectors. One is household and other is investors, businesses. And we will learn that what are the factors due to which GDP, employment level, aggregate demand, aggregate supply increase. In this section we will learn that what are the factors due to which employment level in the economy, due to which output level in the economy, due to which investment magnitude in the economy, economic activities increase. In this section we will learn this. We will learn about, in this section, we will learn about the factors due to which aggregate output and employment level change in two sectors, simple economy. This is a simple economy having only two sectors, household and investors. The factors that change the equilibrium output level, that change the employment level in this simple economy, these factors are as mentioned: aggregate consumption, aggregate saving, and aggregate investment. Let me first elaborate what is simple economy. Simple economy means two sectors economy. The economy in which we have only two parties, two economic units, two decision makers. One is household and the other is investors. Aggregate demand carry two components: aggregate consumption, we are using the symbol C for that, and aggregate investment, again we are using symbol I for that. Aggregate expenditures mean aggregate demand. Aggregate expenditures and aggregate demand carry same meaning, is equal to C plus I. And simply it's mean, as we are defining equilibrium output level, so for the equilibrium output level, macroeconomic equilibrium, we have two forces. One is the force of supply and aggregate supply, and other is the force of demand, yani aggregate demand. That is why I am discussing that in the simple economy we have two components of the aggregate demand. One is consumption of the household and other is investment of the businesses. Yani in this simple economy, the aggregate demand carry two components. One is demand of the household for the goods and services, and other is aggregate demand of the businessmen for the labor, for the capital, and for the raw materials. So C denote aggregate consumption of the household, and I represent investment magnitude, as well as Y represent aggregate output, aggregate supply of the economy. Macroeconomic equilibrium point, we can define the point at which the aggregate output exactly equal to the aggregate demand, and this is equilibrium situation. Y represent aggregate output and C plus I represent aggregate demand of the two sectors, jointly demand of the household plus demand of the investors. And when aggregate supply exactly equal to the aggregate demand, we are saying this is macroeconomic equilibrium. I'm again summarizing this determination of the equilibrium output level. In this section, we will learn that what is simple economy, as well as we will learn what are the factors due to which employment level in the economy and due to which aggregate output level in the economy change. Simple economy, two sectors economy. In the two sectors, we have household and we have investor I. Aggregate demand of this simple economy will carry two components. One is aggregate consumption and other is aggregate investment. So aggregate demand, we formulate that it carry two components is equal to C plus I. Aggregate expenditures and aggregate demand carry same meanings. Aggregate demand carry two components means that we have two types of demand in simple economy. One is the aggregate demand of the household demand for goods and services, and other is the aggregate demand of investors demand for raw material, for labor, for capital, etc., etc. C is the aggregate consumption and I is the aggregate investment. Now equilibrium output level will be that point, macroeconomic equilibrium point, the point at which aggregate output level is equal to the aggregate demand. That point is called equilibrium point in the simple economy. This was little about the simple economy, two sectors economy, and the macroeconomic variables that we will use. The three macroeconomic variables are involved. One is aggregate output supplied, one is other is aggregate consumption, and other is aggregate investment. So we little discuss about the simple economy. That simple economy carry two sectors and aggregate demand carry two components, aggregate consumption and aggregate investment. Now we are coming toward the relationship between the variables. In this section, we will learn about the relationship between the national income Y and the aggregate consumption, aggregate saving and aggregate investment as consumption function, saving function, and investment function. This theory simply means that in this section we are going to relate aggregate consumption with the national income, aggregate saving with the national income, and aggregate investment with the national income. So we are discussing one by one relationship between the aggregate consumption and national income as a consumption function. What is consumption function? Consumption is the function of national income. This is simple function, and function define relationship between the two variables. In this consumption function, we have two variables. One is dependent and other is independent. Dependent variable is aggregate consumption and independent variable is aggregate output. So A is the national income, symbol for the national income in I, that is Y. When this national income Y increase, aggregate consumption of the people will increase. But if the national income Y decrease, again aggregate consumption will decrease. This is the meaning of vice versa. Consumption is the function of national income. National income symbol is Y. As this Y and national income increase, consumption of the people will increase, and vice versa. What does this mean? This means opposite. If the national income Y decrease, aggregate consumption will as well decrease. There is positive relationship between the aggregate consumption and aggregate output supplied. This is the standard form of the consumption function. C is equal to A plus small cy. This small c is multiplying with the capital Y, where small c is marginal propensity to consume. MPC, how we can define MPC? MPC, what is marginal propensity to consume? We can define this MPC, the fraction of the change in income which is consumed is called MPC. It means that part out of the total change in income that consumer consume, that is called MPC. For example, the income changed by $1, and out of this $1, consumer consume already $0.75. So this $0.75 that consumer consume out of the change in income, that is called MPC of the consumer. Yani the ratio of the change in income, it's mean that out of the change in income, the amount that consumer is consuming, we call that is MPC. MPC we can define like this. We can formulate MPC is equal to change in consumption divided by change in income. It means this is the ratio of change in consumption to change in income. MPC is the ratio of change in consumption to the change in income. MPC is equal to delta C over delta Y. I am clarifying, I am elaborating this MPC with one example. Suppose if Y0 is the first national income, $1,000 billion, C0 is the first consumption of the economy, $500 billion. Y1 is the second national income double increase. So consumption C1 also double increase from 500 to $1,000 billion. The question is this: calculate MPC, and you define MPC that MPC is that amount out of the change in income that consumer consume, or you can say the fraction of the change in income which is consumed, which is not saved, that is called MPC. So we find out the change in national income, delta Y delta for change. I am calculating that how much income change, Y1 minus Y0. We subtract the first national income, $1,000 billion, from the last second national income, $2,000 billion. So 2,000 minus 1,000 is equal to 1,000. It's mean the national income changed by $1,000 billion. Now we calculate the change in consumption. So change in consumption is again second consumption in C1 $1,000 billion minus first consumption yani C0 $500 billion. So when we subtract this first consumption $500 billion from the last second consumption $1,000 billion, we find out the change delta C $500 billion. Now as we define that MPC is the ratio of change in consumption to the change in income, means divide the change in consumption by the change in income. So this is formula: change in C divided by change in Y, and MPC is equal to 500 divided by 1000, and we calculate 50%, 0.50. MPC we calculate. Interpretation of this MPC is this: that every Afghan consume 50% of his income, and 50% of his income every Afghan is saving, because we calculate MPC, marginal propensity to consume. The rate of consumption of Afghans we calculate, that is 50%. Now we are defining saving function. Again, saving is the function of national income. Function define relationship between the two variables. So in here also we have two variables. One is saving and other is national income. There is positive relationship between these two variables. When the national income increase, saving will also increase. As the people get rich and rich, they will save more and more, and they will plan. Why they are saving? Because they are planning investment in the future. So saving function define the positive relationship between the saving and national income. There is positive relationship between S and national income Y. Standard saving function is equal to S minus D plus small sy, where this small s is MPS, marginal propensity to save. Again, we can define that MPS is the fraction of the change in income which is not consumed. It's mean that part of the change in income that you does not consume, that you save, that is called MPC. Or we can say the amount out of the change in income which is saved, that is MPS. For example, if income changed by $1 and out of this $1, $0.75 consumed, so remaining 25%, $0.25 that is saved, MPC of this individual is 25% or MPC of this economy, that is 25%. MPS we can calculate. This is the ratio of the change in saving to the change in income. Change in saving divided by the change in income. MPS is the ratio of the change in saving to the change in income. MPS is equal to delta S divided by delta Y. Again, we have the information Y0 is 1000, C0 in aggregate consumption first, that is 500. The second national income Y1 $2,000 billion. The second consumption is $1,000 billion. This is very also clear from these statistics that when income is 1000, consumption is 500. When income double, consumption also double. It's mean positive relationship between the consumption and national income. As a national income increase, aggregate consumption is also increasing. So we will find out the change in saving. S0 yani first saving. First national income Y0 minus first aggregate consumption mean 1000 minus $500 billion. We find out the $500 billion saving. 50% is the MPC. It's mean every individual is saving 50% and consuming 50%. So out of the $1,000 billion national income, $500 billion consumed and $500 billion we find out the saving of the people. Second saving, we can calculate second national income Y1 minus second national consumption, aggregate consumption C1. So second national income is $2,000 billion and second aggregate consumption is $1,000 billion. The difference is $1,000 billion. It means second saving is $1,000 billion. Now we will calculate the increase in saving, change in S1 minus S0. S1 is 1000, original saving, S0 is 500, change in saving is $500 billion. It's mean when the national income changed from $1,000 billion to $2,000 billion, it doubled. The saving also changed from $500 billion to $1,000 billion and it changed by $500 billion. A 50% change. So MPS, change in S divided by change in Y. Change in S we calculate $500 billion, change in Y is $1,000 billion and calculated ratio, that is 50%. Interpretation of the MPS, every Afghan is 50% saving his income and 50% of his income every Afghan is consuming. Now investment. Investment is the important factor in the determination of national income and employment level. This means that investment magnitude or investment in any particular economy determine means increase or decrease the output level of the economy and employment level of the economy. And this is very clear that when investment magnitude increase, many companies invest in Afghanistan. Foreign direct investment, when the foreigners invest in different areas in every sector, automatically aggregate demand for labor, for capital, for raw material will increase. When the demand for labor, capital and raw material increase, jobs opportunities, employment level will increase, per capita income of Afghans will increase, their consumption will increase, again demand will increase, and finally GDP will increase, and GDP will jump from one lower level to the other upper level. It's mean investment magnitude is a better measure to increase GDP, to increase employment level, to increase aggregate demand of the people. Now we are defining simply what is investment. So investment, when the businesses incurred, spent $1 billion to purchase the capital assets, to purchase equipment, machinery, building, offices, houses, increase the capital stock. Why? To manufacture the goods and services, to serve the nation, and ultimately to earn further money. Every investor has the two objectives: serve the nation and earning money. Any economic activities that bring future economic growth, that is called investment. Means any activity that increase aggregate demand, aggregate supply, aggregate employment level, price level, interest rate, investment magnitude, any economic activity which cause growth in the future, that economic activities we call that is investment. Now investment as a function, we define that investment as a function of national income. There is a direct relationship between the two variables. One is I, investment magnitude, and other is Y, national output, aggregate supply. So investment is the function of national income. It's mean in this case, if the national income is increasing, automatically investment magnitude in the economy will increase. So investment is the function of national income. As national income rise, investment will also rise. And when the national income decrease, investment will also decrease. Vice versa, mean opposite case. There is positive relationship between national income and investment magnitude. This is given in the table. National income Y $100 billion. At that time, investment is $50 billion. When the national income double $200 billion, investment also double $100 billion. When further national income increase to $300 billion, again investment magnitude is positively increasing. There is positive relationship between the investment and national output. And investment is the function of aggregate output. Investment is the function of national income. If national income is increasing, automatically investment magnitude in the economy will increase. And if this is decreasing, so automatically investment magnitude will decrease.